For example, if you recall the wheel of fortune, right? That we use to rotate and record the theta, right? If you remember, theta, or where does it stop? So basically, record the angle, or in general, the number at which it stops. At that time, we define the random variable x, which is, for example, theta. Okay. Now, suppose that you have a similar wheel. However, you are not basically rotating it. You are trying to aim at it by a bullet or whatever, arrow or whatever. Just صوب عليه. So basically, in this case, you are interested in where your arrow will land, here, 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 and so on. So you are interested in the location of your arrow in the x-axis and in the y-axis. Okay, so in this case, x can be the x coordinate, x-axis coordinate of bullet, and y can be the y-axis coordinate of the bullet, right? So clearly, x takes value from, suppose that this has a radius of r equal, let's say, certain r, certain radius, let's call it r. So clearly, x can take values from where to where, Shabab? Shabab?
From minus r to r.
Minus r to r, right? And y can take axis again from minus r to r, right? Okay, so basically these are the ranges of x and y. And both of the, basically the bullet can, or the arrow can basically land at any point in this two-dimensional plane. Okay, so in this case, the randomness comes from when you throw the arrow. So the arrow will give you, every time you throw the arrow, it will give you two outcomes, S1 and S2. And you map S1 to X and S2 to Y. Eventually, this is what you are doing. Of course, here we are not discussing, we are not concerned about the sample space or what S's mean, because at this time, S1 means X and S2 means Y. But in other examples, as you will see, the sample space could be different than the X and Y. Okay?
So, Doctor, based on this graph on the left, a value from the sample space can have multiple values, right?
Yeah, a value from no, it will be, again, it will be one sample, one value of sample space can have, yes, multiple values of x, but not the other way around. One value of x cannot take multiple values from s.
Okay.
Okay. Yeah. So it's a typical function.
Doctor, can you repeat, please?
So basically x1. No, تقفل الميكروفون. So basically, one s value can take multiple values in x or y, but not the other way around. Not one x value can be mapped from more than one value from S space. So it's a typical function. A function.
Doctor, this is unlike the random variable for one variable, right?
No, it's the same. So basically, the function, you cannot have a function like this, right? You cannot have one value from S, for example, S, it takes multiple values from X. So if this is S and this is X, you cannot have one value from S takes different values of X. However, you can have a function like this. One value of S can take, one value of X can be mapped into from two values, from S1 and S2 method. So basically, one value of S can take only one value of X and Y. Okay. However, not the other way around. One value of X, one value of S cannot take more than one value of X and Y. but more than one value of S can take one value of X and Y. واضحة ولا لخبطكم أنا؟ So look at it as a function here. When you have a function, this is not a valid function. This is a valid function. واضح؟
واضح ده.
واضح.
Okay, so basically here, what we have mapping here is S1, for example, one outcome. في one random variable كان one outcome mapped into a specific X, right? X1. And another outcome mapped into another X2. This is in single random variable, X. However, in multiple, for X and Y, two random variables, X and Y, every S is mapped into a pair of X1, X2, or Y1. And another outcome is mapped into another pair, X2, Y2. So this is the experiment outcome, sample space outcome. Outcomes. And this is basically the value in two-dimensional X, Y plane. واضحة؟ واضحة يا شباب؟
Yes.
Instead, in this particular example, you can define another two random variables. If you are interested in the location of the arrow that lands in this two-dimensional plane, you can define R, another setup. You can define R, which is the radius at which bullet lands, right? And theta is the angle at which bullet lands. So in this case, every time you will look at where the bullet lands, you will check what? You will check the theta and the R. Yes. So in this case, R, what is the range of R, Shabab? What are the values
We
that R
said
can take?
from
Zero.
R to minus
From
zero
where?
to R.
From 0 to
From
R.
0 to
To
R,
R.
yes. Exactly. And the theta?
From 0 to 2 pi.
0 to 2 pi, exactly. Okay? تمام يا شباب? So basically this is, in this case, we have two random variables instead of one random variable. One random variable does not give me the answer because the two-dimensional location in a two-dimensional plane cannot be described by a single random variable. X or Y or R or theta, it cannot. So in this case, I am mandated to use two random variables. تمام? Another example is the weather. For example, assuming that the weather is mainly controlled by the temperature and the pressure of the atmosphere. In this case, in predicting the weather tomorrow, you cannot. It's not enough for us. خلينا نتكلم عن الشرقية، المنطقة الشرقية. بلاش نتكلم عن البريشر. Let's talk about temperature and humidity. Okay, الرطوبة والحرارة والرطوبة. So in describing the weather tomorrow or after 1 month, it's not enough for us to say that the temperature is 20 or 30. You need to mention the humidity factor. So you can say that the temperature is 30 and the humidity is 90%. Or the temperature is 20 and the humidity is 50%. So in this case, you need two random variables to describe the weather, not only a single random variable. هذا مثال. طبعا الويذر بالعاده في عندك many random variables that control the weather, not only one of them. However, just for simplicity. طيب يا شباب. So basically, this slide summarizes what we have talked about. A vector of random variables is called a random vector. Okay, where a random vector, a random variable x, which is mapping from S to the line, and another random variable y, which is another mapping from S to the real line also. So you can define the random vector as a random vector Z, which is X and Y, which is a mapping from S to R squared, to the two-dimensional space. Okay? So every time you define Z, basically you define X and Y. A pair, X and Y. طيب يا شباب؟ Now in general you can have n-dimensional random vector. Very similar concept. N-dimensional random vector. In this case, the random vector will contain n values. So it's a mapping from the sample space to R to n. It's an n-dimensional random vector. In this course, we will mainly focus on two-dimensional. However, in some cases, we'll talk about more than two-dimensional. Everybody understand what I mean by vector, right? Ashwa? Everybody understands the vector.
Yes, doctor.
You have taken it somewhere in your math. طيب. So let's have an example, a numerical example. We have here tossing two coins. When we toss two coins, we know the sample space. It has 4 outcomes: head, 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 tail, tail, head, tail, tail. And we know that the probability of every one of them is 1/4, 1/4. Tamam? Now we can define different random variables. One of the random variables that we have already defined it in chapter 2 is the number of heads. Can you have the mapping HH when head head you have 2, and when you have head tail you have x equal 1. This is x of تتذكروا x كان عبارة عن x of s, right? كان عبارة عن function of the sample space of the outcome. So x of tail head equals 1 and x of tail tail equals 0 because the number of heads is 0. Now تذكروا هذا example. Okay? And we talked about the distribution of this and so on. Now تذكروا كان basically you have 0 with 1/4 probability, and we have what? 1
half probability.
with half. This is 1/4, 1/2, and we have 2 with 1/4. تذكروا PDF of x. Okay, and we also plotted the CDF and so on. Now we can define another random variable y, which is the indication of similarity. ايش يعني similarity؟ يعني if you have 2 heads, you map it into 1. So 2 tails, you map it into 1. So they are similar. The outcomes of the 2 coins are similar. Or you can say if the outcomes are different, I map it into -1. Okay? واضح يا شباب؟ So in this case, how does the PDF look like? Why? What are the outcomes of y? What are the values that y takes?
Will be 1 and -1.
-1 and 1, exactly. Each with a probability
Of half.
half, because they happen equally likely. Tamam? Now, in this case, I can define 2 random variables, x and y. So now, x and y, so if this is the outcome, space S, I have head, head, I have head, tail, I have tail, head, I have tail, tail. Now, if this is S, then what is x and y value? So now we are talking about 2 random values, not only a single one. So if I have head, head, what do I get? What are the values of x and y?
X will be 2
Yes?
and Y will be 1.
Yes. Head, tail.
X will be 1
Yeah.
and Y will be -1.
Because they are different. Tail, head,
X
One
will
and
be
minus
1.
one.
نفس الشيء right and tail we have
Zero and one.
0 and 1. Okay, so in this case this is the mapping of S to two random variables. تمام. Now I can now talk about the probabilities. What is the probability that x equal 2 and y equal 1? Well, this happens when, يا شباب? When x equal 2 and y equal 1 is this. When does this happen? When
1/4 when it is
yeah,
head.
1/4, which is when head. So I can map now the corresponding event in x and y to the corresponding event or the corresponding outcome of the sample space. I can map back, which is a probability of head, which is 0.25. Now we call this as the joint probability. The joint probability. Okay. Similarly, I can find the probability that x equal 1 and y equal 1.
That cannot happen.
Will never happen. Why? Because x equal 1 means we have one head. One head معناها الثانية tail. So y cannot be 1. Because y means that they are similar, either head or tail. Excellent. So this is equal to the probability of phi, which is 0. Or you can look at it from the probability of x equal 1 and this is like and y equal 1, which is equal to the probability that the event underlying x equal 1. So x equal 1, what does it mean? We have head, tail, and tail, head. Intersection and means intersection. The corresponding event for y equal 1. When does y equal 1? When you have similar outcomes, right? So this is corresponding to y equal 1. And this corresponds to x equal 1. And this is the intersection between them. تمام?
You mean x equals 0, doctor?
X equal 1. Why? This is the probability that x equal 1. Ask it here.
ايوه معلش.
تمام? So basically, I can define now the probability of any two events on x and y jointly. نسميها joint probability. مثلا هنا, let's talk about the probability that x is strictly less than 1 and y strictly larger than 0. When does this happen? X less than 1 means what? It means x equal. We don't have it. So basically means that tail.
Tail, yes.
Yes. And y is strictly larger than 0 means what?
Must be tail and head.
Or head. So basically you have here similar. So this is basically what this. Now intersecting them, you can see that you can have only tail, which is 0.25. تمام يا شباب؟
تمام دكتور.
أي سؤال؟
Doctor, and sort of this example, we refer to the experiment. We don't deal with the random variable directly.
إيه لأنه هنا في underlining experiment واضحة بالنسبة لنا اللي هي tossing the coin twice. Well, definition of the random variable comes from or stems from the experiment. بينما مثلا هنا when you throw the arrow, throwing the arrow is the experiment. So it's directly related, يعني ال x وال y directly related to the throwing the arrow. واضح؟ واضحة؟
Yes.
يعني basically the sample space in this case is directly defined as the random variable على طول. نفس الشيء الويذر لما قلنا الويذر is a function of temperature وال humidity. Well, temperature and humidity are two random variables and they are the outcome of the experiment at the same time. لكن هو in general زي ما قلنا احنا ال random variable is defined as a mapping from the sample space to the R. مرات السامبل سبيس تعطيك real numbers على طول، مرات لا. مرات تعطيك outcomes, descriptive outcomes. You need to map them. واضحة؟
Yes.
طيب الآن we need to understand now how to define joint probabilities, which will lead us to defining the joint distribution function or joint CDF. Okay, so you need to feel comfortable about this. Now, if I just complete the table here, probability of the first one is every one of them is 1/4, right? Type. Now the joint distribution and its property. What is joint distribution? Well, the joint commutative distribution or joint CDF is defined as follows. It's defined as if I define very similar to what I just did here, certain joint probabilities. مثلا I define A as a certain event on X and B as another event on Y. Okay? So A, if this is the two-dimensional space, then A can be X less than or equal specific X. So basically this is A, the blue line here. While B is Y is the event corresponding to Y less than a specific value. So basically it's everything that is less than Y. It's the green part. Then I can define the probability that X is less than X and Y and Y is less than Y, which is the probability that A intersect B. لأنه A هو X less than X and B is Y less than B, which is the shaded region here, which basically gives you X less than X and Y less than Y. تمام? In this case, the joint probability distribution function of X and Y is defined as this. If X and Y, so these are the random variables, and these are the dummy variables. زي ما سوينا مع single random variable, which is defined as the probability that X is less than this number, small x, and Y is less than this small number Y. تمام? So if X and Y of X and Y is a two-dimensional function, because it depends on X and Y. It's a function of X and Y, the coordinates X and Y. In general, you can have three, for example, random variables. So these are three random variables: X1, X2, X3. So if of X1, X2, X3 of X1, X2, X3 is equal to the probability that X1 is less than a small number X1, X2 is less than a specific number X2, and X3 is less than a specific number X3, and this is intersection. فاصلة معناها intersection. فاصلة معناها intersection. When you see فاصلة معناها intersection. طيب شباب? So this is in terms of definition. We'll talk about some examples in a minute. So let's have this example. We have here two random variables defined as follows. Defined such that the probability that X equal 1 and Y equal 1 is 0.2. The probability that X equal 2 and Y equal 2 is 0.3. And the probability that X equal 3 and Y equal 3 is 0.5. Okay? So if we look at it in two-dimensional space, x and y, if this is x and this is y, and this is, we'll come to it later, this is the joint density. لكن يعني bear with me that whether you call it density or not. So the distribution over x and y هذه البوينت has a probability of 0.2. So 1 in the x, 1 in the y, you have an impulse here with 0.2. هذا الإمبلس الأولى. And at x equal 2 and y equal 1, we have another impulse of 0.3. And we have the last one, which is at x equal 3 and y equal 3. We have the last impulse. So basically, the two random variables are distributed according to these three fingers. هذا وهذا وهذا. There are no other possibilities. So there is x and y cannot take other values. بمعنى the probability that x equal مثلا 2, y equal 3 equal كم يا شباب؟
0.
0. It cannot happen. So x and y cannot take other values. ليش؟ لأنه this is by definition. We define the two random values accordingly. Defined so. أعطيك مثال ثاني ممكن يكون مختلف. لكن this is defined so. So in this case, let's see the CDF of x and y evaluated at 2 and 1.3. What does this mean? احنا دائما نرجع للدefinition. When you talk about CDF, we always go to the probability definition. CDF of x and y at 2 and 1.3, what does it mean? It means that this is equal to the probability that x is less than 2 and y is less than 1.3. This is by definition. Right? واضح يا شباب؟
واضح دكتور.
And from here we ask ourselves, when does x become less than or equal to 2? من هنا من ال distribution هذا أو ال joint probabilities. When does x become less than or equal to 2?
The first two options.
The first two options. هذه وهذه. And when does y become less than or equal 1.3?
The two options also.
Also the first two options. So this is equal to the joint probability of 1, 1 and 2, 1. Right? And we know that the probability of the first is 0.2 معطى. The probability of the second is 0.3 given also here. So this probability is equal to 0.5. This CDF value is equal to 0.5. تمام? Now this is called joint distribution function. Joint distribution function. Because it deals with the distribution function of both x and y. واضحة الjoint? Then we will define now in a minute what we call the marginal probability. And marginal probability deals with or means that I'm talking about the probability of only a single random variable. مثلا, I can ask in the context of two random variables, x and y, I can ask about what is the probability that y equal 1. This is called marginal probability on y. Because I'm asking about y alone without x. So this is not a joint probability. This is only a marginal probability. واضحة؟ So in order to find what is the marginal probability of y equal 1, I ask myself, when does y equal 1?
When x equal to 1.
Yes.
And x equal to 2.
Basically, we have 3 fingers here. So y equal 1, excellent. Happens when in the finger located at 1, 1, when x equal 1 and y equal 1, and when x equal 2 and y equal 1. So happens y equal 1 here is here. So basically you look at everything located at y equal 1. You can see that it has two values. When x equal 1, هذه الvalue, and when x equal 2. So I sum everything related to this point, to this line, y equal 1. So it's equal to 0.2 plus 0.3. تمام؟
تمام دكتور.
طيب. Now y equal 3. This is another margin probability. The probability that y equal 3. When does y equal 3?
Only when x equal to 3.
Equal 3.
Yeah, I look at the graph here. Y equal 3 means this. Only one value of x corresponds to it. So this is the probability of the 0.33, which is 0.5. Excellent. تمام. طيب يا شباب, send me over the private chat. What is the probability that y equals 2 over the private chat? Over the private chat, شباب. What is the probability that y equal 2? Over the private chat. Quickly, يا شباب. طيب. Everybody sent already? طيب, I have seen most of you have done it right. This is equal to what? When does y equal to? Here, huh? Do we have any finger at y equal to?
No, دكتور.
يحرك الشاي, قفل الميكروفون الله يخليك. So at y equal to nothing, 0. So it has 0 probability. And you can see from the definition of probabilities, y cannot be equal to 2. واضح يا شباب? Similarly, we can ask what is the probability that x equal 1? Again, this is marginal because I'm asking only about one random variable out of the two. So when does x equal 1? I look at the PDF. I can see only one value in y, which is the probability of 1, 1. X only takes value when y equal 1, and this is equal to 0.2. Similarly, probability of x equal 2. It's the probability that x equal 2 and 2 and 1, right? So x equal 2 is this. I can see only one value of y, which is 0.3. Similarly, x equal 3 happens only when we have 3 and
3 and 3.
Thank you. Yes, which has a probability of 0.5.
Doctor, the probability of y equal to 2, can I say it's phi?
Yeah, here. It's equal to a probability of phi, not phi. يعني انتوا لازم يا شباب الان يعني by this time in the course we need to distinguish between the probability and the set. This is a set. This is a probability. ما تقدر تقول probability equal phi. نفس شيء اسمه probability equal phi. Probability only can take values from 0 to 1. Now you can ask yourself what is the corresponding set to y equal to. The corresponding هذا الآن y equal to, what is the corresponding event? Event in S. It's equal to 5. نحن هذا اللي نسويه. In order to find the probability of y equal كذا, we go to the corresponding event in S.
Yes,
if it is phi, it's 0. معناها the probability equals 0. تمام؟ لازم الشباب دائما نميز بين probability وبين الست أو corresponding event. طيب ممتاز. So now let's talk about the joint distribution and its properties. الجوينت distribution احنا بس خلينا نكتبه هنا مرة ثانية. fx and y of x and y equals by definition the probability that x less than small x and هذه معناها and ها y less than or equal small y. ما حنصير نكتب and، خلاص حنصير نكتب فاصلة. فاصلة معناها and. خلاص. From this chapter onward فاصلة معناها and.
تمام دكتور.
means and. تمام. So basically the probability, this is the joint CDF. Now let's talk about its properties. Our property is what is the value of fx and y at minus infinity and minus infinity. دائما قبل ما نقول أي كلام we go to the definition. Simply I'm asking about here what is the probability that x is less than minus infinity and y less than minus infinity. This is equal to 0. Okay? X cannot be less than minus infinity and y cannot be less than minus infinity. تمام؟ واضح يا شباب؟
Yes.
Similarly, if I put minus infinity in x or in y only, I always get 0. Which means that this, the first one is, what is the probability that x less than minus infinity and y less than a specific number? Well, there is an and here. And because of that, because there is and, x cannot be less than minus infinity and y can be any value. This is impossible. X cannot be less than minus infinity. And because of that, the answer is 0. تمام? Similarly, y cannot be less than minus infinity. So if x of x and minus infinity means that this is equal to the probability that x less than a specific number x and y less than minus infinity. But y less than minus infinity is an impossible event. The intersection between impossible event and any event is what?
Phi.
Phi. So this is خلينا بس نشرحها. هذه عبارة عن probability that x less than or equal small x and y less than or equal minus infinity. Now this is equal to the probability of phi because this is phi corresponding to phi. So the probability of phi intersection with anything is what?
0.
0. خلينا بس اكتبها بالتفصيل. Less than or equal x and phi. And this is equal to the probability of phi, which is 0. تمام. Okay. Similarly, I can ask what is the probability that what is the CDF evaluated at infinity and infinity? This is equal to the probability that x less than or equal infinity and y less than or equal infinity, right? But when does x less than or equal infinity? The whole sample space.
All the time, yes.
And y less than minus infinity is the whole sample space, which gives you 1. تمام يا شباب؟ So this is S intersect S, which is 1. طيب. So this gives us هذول الاثنين يعطونا ايش the conclusion that the joint CDF can always be between 0 and 1. It cannot be less than 0. It cannot exceed 1. So it's a two-dimensional function that goes from minus infinity and it is 0 at minus infinity of both x and y, and it goes all the way, increases up to 1 when x and y approaches infinity. واضح؟ Similarly, if y of x and y is non-decreasing in x and y, non-decreasing function. ليش؟ Because every time I include x, if I include more x, I either increase the probability or the probability stays as it is. كل مرة I go x, I increase x, either I include more events, right, or the same events, which has the probability of either equal or larger. Similarly, if I increase y from here to here, I either increase the number of events involved in the probability, which increases the probability, or the number of events stay the same. And hence, it cannot be decreasing with x and y.
Doctor, can you repeat this point?
يعني الفانكشن هذا ال fx هذا ال fx in xy, it's the probability, it's equal to the probability that x less than specific x and y less than specific y, صح? Now, if this is x and this is y, then this is basically the event that I'm talking about its probability, أو اللي I'm interested in, right? صح?
Yeah.
Now, if I look at another x which is larger, هذه البوينت, y which is larger, هذه البوينت. Now, increasing x will only include more events. يعني probability either increases or stay the same, صح ولا لا؟
صحيح.
Similarly, y, increasing y will include more events. So either the probability stays the same or increases. It cannot decrease. So including more values of x and y will have the probability to increase or stay the same. It cannot decrease. واضحة؟
ايه واضحة دكتور.
تمام. Okay. Now let me talk about the sixth property. قبل ما نروح على الفifth. Sixth property states the following. If I put infinity at y, what does this mean? This is equal to the probability that x less than or equal x and y less than or equal infinity, right? Which is equal to the probability that x less than or equal x intersect with s, right? I know that y equal infinity means s, the sample space. صح ولا لا?
Yes.
صحيح.
So now, what is the intersection of an event with the sample space?
The probability of the event itself.
The
The same.
event, exactly. Which is by definition fx of x. Now, this is called the marginal CDF, or marginal distribution.
If you wrote
Okay.
this the PDF of single variable
CDF.
x.
Yes, exactly. This is the CDF
yes.
of a single variable. اللي هو CDF of x. Exactly. نسميه لما يكون عندنا two random variables نسميه marginal. يا تسميه marginal CDF of x أو تسميه CDF of x. نفس الشيء. نحن كنا نسميه CDF وهذا اسمه طبعا. لكن لما يكون عندك two random variables إذا البروبلم الكونتكست فيه two random variables we call it marginal. Similarly, واضحة يا شباب هذه؟ Similarly, if we put infinity in x location, then this gives you the marginal in y, fy of y. تمام؟ واضحة؟ Now, if I have four random variables, x, y, z, w, and I put infinity in y and infinity at w, this gives me the marginal or the joint in x and z only. Basically, y و w يختفوا لأنه خلاص ما عاد. We are talking about y less than infinity and w less than infinity. But there's no point of talking about it. تمام? So next time, inshallah, we'll talk about property 5 and we'll illustrate it in a graphical way such that it is very clear to you. And we'll continue, inshallah, with the joint CDF. أي سؤال يا شباب؟ I think time is up already. Any question?
The next quiz will be in Sunday, yes?
Next Sunday, yes. بإذن الله. سؤال ثاني يا شباب. Okay. So we'll see you inshallah on Thursday بإذن الله.